Halo semuanya, di video kali ini Koko akan lanjutin lagi pembahasan Past Paper EJU tahun 2018 untuk first sessions course yang kedua. Kalau di video sebelumnya Koko udah sempat bahas soal pertama sampai soal kelima. Di video kali ini Koko akan lanjutin ke satu soal terakhir yaitu soal ke-6 atau soal dari section keempat. Bagi kalian semua yang mungkin belum nonton video-video pembahasan sebelumnya, kalian bisa klik link yang ada di description. Dan jangan lupa untuk subscribe channel YouTube Koko, supaya kalian bisa terus dapat update ketika Koko mengupload video pembahasan yang lainnya. Oke, kita langsung aja lihat soal terakhir dari Past Paper 2018 First Session course yang kedua. Let an equals to integration from 0 until 1 of x to the power of 2n square root 1 minus x squared dx, where n is equals to 0, 1, 2, and so on. The objective of this question is we are to find the value of the limit n approach infinite from a of n over a of n minus 1. This is the objective of this question. We want to find the limit of n approaching infinity of this function. First of all, let us find a0 and a1. So first of all, we want to find a0 and a1. Since the area of a circle with radius 1 is pi, we see that a0 is equals to this, is equals to pi over blah blah blah. If we want to find a0, we just substitute n with 0. So x to the power of 0 is equals to 1. So the x to the power of 2n here becomes 1 in our expressions. If we want to find the integration of this, it's very similar as this integration is the area below the curve this from 0 until 1. So the result of this integration is basically the area. Area below y equals to square root of 1 minus x squared from x equals to 0 until x equals to 1. X equals to 0 to x equals to 1. If we sketch this equation or this curve, before I sketch this, I can square it both sides first. We will obtain y squared is equals to 1 minus x squared, and if I move minus x squared to the left hand side, I will get x squared plus y squared equals to 1. This is the equation of a circle where the center is 0, 0, and then the radius is 1. So if I sketch this graph, I will obtain a circle with radius 1, as they said before. But I only want to find the area from x equals to 0 until x equals to 1. This is our circle. If I sketch this, it should be something like this. Let's say that's the circle. The center is 0, 0, and then the radius is 1. This is the center, and this is the radius. We only want to find the area from 0 until 1. From 0 until 1. So what we want to find is only 1/4 of the area of a circle. So the result of this integration, basically the area of 1 over 4 of the circle with radius 1. If the circle of radius 1 has an area of pi, so if I only want to find the area of 1/4 of the circle, then the area of this shaded region is pi over 4. So basically the result of this integration is pi over 4. Therefore, letter A here is 4. This is the first thing that we have to do. We want to find A0. How about A1? To find A1, we should apply partial integration method. Partial integration method is usually said as integration by parts. Next, the partial integration methods applied to A1. So we want to find A1 by using integration by parts. If I want to find A1, just substitute n by using 1. 2 times 1 is 2, and then 1 minus x squared dx. We have to find the integration of this by using integration by parts. Since I think I need more space here, so let's move to the next page. This is the questions. I will use integration by part methods to solve this integration. Integration by parts methods has formula something like this. Integration of u times dv, or integrations u dv, is equals to uv, u times v, minus integration of v du. So if we want to use integration by parts, we have to know which part is u and which part is dv. First of all, I have to manipulate these integrations first. X squared here, I will write as x times x. So A1 is equals to integration x times x. X times x is x squared, and then square root 1 minus x squared. 1 minus x squared dx. The limit of the integral is from 0 until 1. This is u, and the other part is dv. So x is u and the other part is dv. This is our u, this is dv. The part dv or the dv should be integrated so that we can obtain v. So if dv equals to x, 1 minus x squared to the power of half dx, to obtain v, we should integrate these expressions. If I integrated both sides, I got integration of dv equals to integration of x, 1 minus x squared to the power of half dx. Integration of dv, basically this is integration of 1 dv. Integration of 1 dv is v, is equals to integration of this part. We should use integration by substitution. So I will let 1 minus x squared as a. Let a equals to 1 minus x squared. If we differentiate it, I got dA dx is equals to negative 2x. So dx is equals to dA over negative 2x. Let's substitute this into that. If we substitute it, I will get v equals to integration x. I will leave it as x because it will cancel out with this x, times 1 minus x squared is a, to the power of half, dx is dA over negative 2x. If we cancel out the x, I will get v equals to, just move the constant outside the integration, negative half integration of a to the power of half dA. I think you can do it by yourself. A to the power of half dA. If we integrate that, I will obtain negative half a to the power of 3 over 2 divided by 3 over 2 plus c. If we simplify half divided by 3 over 2, we will obtain negative 1 over 3. So this becomes negative 1 over 3. Plus c. And then just substitute back the a. A is 1 minus x squared. I will get v equals to minus 1 over 3 times 1 minus x squared to the power of 3 over 2 plus c. We already get the variable v here. So let's back to the questions. By using integration by parts, a1 is equals to u times v minus integration of v du. By following the equation, u is x, so x times v, v is negative 1 over 3 blah blah blah. I will not write the plus c here because we have definite integrations. So plus c is not needed if we deal with definite integrations. X times negative 1 over 3, 1 minus x squared to the power of 3 over 2, minus integration of v. This is our v. We do not need to write plus c there because we are dealing with definite integrations. So the v is only negative 1 over 3, 1 minus x squared to the power of 3 over 2. Let's move it. Okay. And then du. Basically, du is the derivative of u. If I have u equals to x, if we differentiate it, I will get du dx equals to 1. Then du basically equals to dx. So du is dx. Okay. Since on the first expression, there are no integrations anymore, we can substitute the upper and lower limit to these expressions first. So the boundary can substitute it into this, but on the second part, since there's still an integration, we cannot substitute the upper and lower limit here. We should integrate it first. So if I substitute the upper and lower limit to the first expression, if I substitute 1, you can imagine it by yourself. If you substitute 1, 1 times negative 1 over 3, 1 minus 1, which is 0, it becomes 0. 1 times negative over 3 times 0 is equals to 0. So the upper limit is 0 minus the lower limit if you substitute 0 in here, you got 0 times blah blah blah. It should be 0. So the first expression here will give us a result 0. 0 minus 0. And then minus times negative, it becomes plus. I will move the constant outside the integration. Integration of 1 minus x squared to the power of 3 over 2. 1 minus x squared to the power of 3 over 2 dx. Wait a minute. Let us see the answer here first. The answer in here is the result in here. So I think b over c is 1 over 3. So b is 1, c is 3. b is 1, c is 3. x 1 minus x squared d over e. Then d over e is 3 over 2. 0 until 1. And then plus, negative times negative is plus, f over g. So f over g is 1 over 3. Integration of 0 until 1. 1 minus x squared to the power of h over I. Then h over I is 3 over 2. We already get the second row here. And finally, we have to simplify the second row to obtain the third row. So let's continue our working here. I got a1 is equals to 1 over 3 integration from 0 until 1. From my working, it's only one expression. But if you see from the format here, they got two expressions. And there are square root of 1 minus x squared there. So I think we have to manipulate these expressions. 1 minus x squared to the power of 3 over 2 is the same as 1 minus x squared to the power of 1 times 1 minus x squared to the power of half dx. 1 minus x squared to the power of half is square root of 1 minus x squared. So I will change it into square root 1 minus x squared. And then if you multiply that, we got a1 is equals to 1 over 3 integration of 0 until 1. 1 times square root of blah blah blah. Square root of 1 minus x squared minus x squared times blah blah blah. I got x squared square root of 1 minus x squared dx. And then we can separate the integrations here because we get a subtraction. So I can write it as 1 over 3 open bracket integration of 0 until 1 square root of 1 minus x squared dx, this is the first part, minus integration from 0 until 1 x squared square root of 1 minus x squared dx. This is the second part. And I think we already got the value of j, k, and l. J over k is 1 over 3. And then integration of 0 until 1 blah blah blah, it's here. Minus x to the power of l. So l is 2. L is 2. And then thus we have a1 is equals to blah blah blah. We have to calculate a1 until we got the answer. We have to calculate this. How to calculate this? If you observe the first part of our integration is equals to A0. This is basically A0. If we move to this, that is A0. So integration from 0 until 1 from square root of 1 minus x squared is A0. Minus, how about the second one? If you remember the second one, or the second expressions, the second expression is A1. It's the same, right? X squared, square root 1 minus x squared, square root 1 minus x squared. So our second expression here is A1. We want to find the value of A1. Just cross multiply the 1 over 3 to the left hand side. I got 3A1 equals to A0 minus A1. I will get 4A1 is equals to A0. Then A1 is equals to 1 over 4 A0. A1 is 1 over 4 A0. What is A0? A0 is pi over 4. We already calculate it first. A0 is pi over 4. So A1 is equals to 1 over 4 times pi over 4. And then the final answer is pi over 16. So the value of m and n here is 1 and 6. That's the answer for A1. Okay, let's move to the next questions. For O until U in the following sentences, choose the correct answer from among choices 0 until 9. So this is multiple choice questions, yeah. From O until U, we have to choose the answer from this. The question says, when the partial integral method, once again, when we use integration by part to an, so we talk about more general formula of an in the same way as for A1, we get an equals to blah blah blah. So we need to find an by using the same way or same method for A1. And we will obtain this. Let's move to the next page, since I think I need more spaces to calculate or to do the working. An is equals to blah blah blah. What is an? An is equals to integration from 0 until 1 x to the power of 2n square root 1 minus x squared dx. This is our an. And then by using the same method, we need to find OPQR by using the same method. If you remember, when I find A1, the x here is being manipulated first. So x to the power of 2n here, I will write it as x to the power of 2n minus 1 times x times square root of 1 minus x squared dx. And then this is u, and then the second part is dv. It's very similar as the previous one. This is u, this is dv, and if you remember it, dv is the same as the previous one. The dv is the same. Since dv is the same, so v is equals to this. I will just copy it. So we already know v. V is this. This is our v. By using the same formula of integration by parts, we will get an equals to u times v, times v minus integration of v, this is our v, minus 1 over 3, 1 minus x squared to the power of 3 over 2 times du. What is du? To find du, we have to differentiate our u. U is equals to x to the power of 2n minus 1. If we differentiate it, I got du dx is equals to 2n minus 1 x to the power of 2n minus 2. Then du is equals to 2n minus 1 x to n minus 2 dx. This is du. U times v minus integration of v times du. Our du is this. So times 2n minus 1 x to the power of 2n minus 2 dx. We have to simplify these expressions. The first expression do not have any integration sign, so we can substitute the upper and lower limit here, 0 until 1. And it's the same as the previous one. When you substitute 1, 1 minus 1 is equals to 0, 0 times blah blah blah. Once again, it will equals to 0. And then if you substitute the lower limit, which is 0, 0 to the power of 2n minus 1 is 0. 0 times blah 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 is equals to 0. And then negative minus, it becomes plus. 1 over 3, I will move it outside the integration sign. Integration of this thing. 2n minus 1 times x to the power of 2n minus 2 times 1 minus x squared to the power of 3 over 2 dx. And then if we use the same way as the previous questions when we find a1, I will separate this expression into 1 minus x squared times 1 minus x squared to the power of half. So I will get an is equals to, I think 2n minus 1 here, I will move it there. So we got 2n minus 1 over 3, integration from 0 until 1, x to the power of 2n minus 2 times, separate this into 1 minus x squared times 1 minus x squared to the power of half dx. 1 minus x squared to the power of half, basically square root of 1 minus x squared. I will change this into square root 1 minus x squared. And then if we expand this times 1 times that, we got an equals to 2n minus 1 over 3 integration 0 until 1, this times 1 times that, it becomes x 2n minus 2 square root 1 minus x squared, and then this times negative x squared times that, it becomes negative x to the power of 2n, negative 2n plus 2 will cancel out or becomes 0, square root of 1 minus x squared dx. Once again, I will separate these two expressions. I will get an equals to 2n minus 1 over 3, open bracket, integration of 0 until 1, x to the power of 2n minus 2, square root 1 minus x squared dx, minus integration from 0 until 1, x to the power of 2n square root 1 minus x squared dx. I think this is the answer. So O is 2n minus 1, P is 3. O is 2n minus 1, P is 3. So O is number 6. And then P is 3. 3 is number 3. And then integration from 0 until 1. X to the power of 2n minus 2. X to the power of 2n minus 2. 2n minus 2 is number 5. Square root of 1 minus x squared. Minus integration 0 until 1. X to the power of 2n. 2n is number 7. We already get O, P, Q, and R. And then, hence we have blah blah blah. We have to express an in terms of an minus 1. We have to express an in terms of an minus 1. If you observe this expression basically an minus 1. An is equals to integration x to the power of 2n square root 1 minus x squared dx. If we change n into n minus 1, we will get this. So the first expressions here is an minus 1. And then the second expressions here is basically an. An minus 1 minus an. If I multiply the 3 to the left hand side, I got 3an equals to 2n minus 1 times an minus 1. And then 2n minus 1 times negative an. Negative 2n minus 1 an. Let's move this expression to the left hand side. So we can find the value of an, or we can isolate the an. I got 3an plus 2n minus 1 times an equals to 2n minus 1 times an minus 1. If we factorize the an, I got 3 plus 2n minus 1 times an is equals to 2n minus 1 an minus 1. And then the final result is 2n plus 2 an is equals to 2n minus 1 an minus 1. So the letter S and T here is, S is 2n plus 2. 2n plus 2 is number 9. And T is 2n minus 1. 2n minus 1, number 6. And so, this is the final questions or the objective of this number. And so, the limit n approaches infinite of an over an minus 1 is equals to blah blah blah. We already know that 2n plus 2 times an is equals to 2n minus 1 times an minus 1. So if I divide an minus 1 to the left hand side, an over an minus 1 and 2n plus 2, we divide it to the right hand side. So an over an minus 1 is equals to 2n minus 1 over 2n plus 2. So limit of n approaches infinite of an over an minus 1 is equals to limit n approaches infinite of 2n minus 1 over 2n plus 2. If I multiplied it by 1 over n over 1 over n, I will get limit n approaches infinity. 2n times 1 over n is 2 minus 1 over n over 2 plus 2 over n. And then if I substitute infinity into n, I will get 2 minus 1 over infinity over 2 plus 2 over infinity. As you can see here, 1 over infinity is approaches 0. 1 divided by very large number, it will approaches 0. The same thing of 2 over infinity. 2 over very large number is approaches 0. So the final result is 2 over 2, which is 1. So letter U here is 1. Okay, I think that's it for these questions. I really hope that you guys can understand my explanation here. Thank you for watching this video and see you guys on my next video. Thank you and bye-bye.